today's goal of this lecture. Today I will see what is the relation between directional derivative and partial derivative. This is today's goal of this lecture. But this is just as a review part because till long day I have not discussed about functional several variable. So at first I will hardly recommend you please see my playlist of functional several variable. If you don't see my previous video of functional several variable, at first see those video because today's part just as a review part. At first see what is the definition of directional derivatives, okay? Just as a review. What is the directional derivative? Let S be subset of Rn and consider the function f from S to Rm defined on S. Consider S be subset of Rn and consider one function f from S to Rn where Rm, where S, this is subset of Rn. Okay? And the function defined from S to Rm. Okay? Take one interior point C which belongs to S and consider 0 not equal to u belongs to Rn since C an interior point. C is an interior point of the subset A. So there exists obviously one ball where radius r greater than 0 such that B R C this ball contain in S. Consider CB interior point in the subset S. And since C is interior point, so consider there exists a ball BRC who is contained in this S and consider A is B small, A is B a real number which is small enough so that C plus A is U. Consider this is the A's, then C plus A is U would be this. C plus A is U obviously belongs to this ball, means this ball. Okay? Then obviously this point is FC and this point is f of C plus A is U. Now the directional derivative of f in the direction u is denoted as f prime cu and f prime cu equal to limit h tends to 0 f of C plus u C plus A is u minus f of C divided by h. And this difference f of C plus A is u minus f of C, this difference is the change of value of f when function moved to C plus h. If this is f of C, then this is f of C plus A is u, then this is the difference f of C plus A is u minus f of C when change the function from C to C plus h. And whenever the limit exists divided by h where h goes to 0, whenever this limit exists then f prime cu, that means determine the rate of change of the function in the direction of u at the point C. This is actual geometry of directional derivative. Derivative means derivative exists in all directional. If we choose the ith coordinate ei in Rn, this would be 0, 0, 0, ith coordinate would be 1 and other part would be 0. This is belongs to Rn. Then directional derivative f prime at the point C with ith coordinate is called actually ith partial derivative. and which is denoted as directional derivative in the direction I at the point C. This is actually the ith partial derivative. We all of us know the partial derivative means this is the derivative exists in the coordinate wise, but directional derivative means derivative exists in all directional. Now I will see our actual goal of this lecture. Partial derivative exist mean that does not imply directional derivative exists in all direction. Let's see this idea by one example. Consider one function f which is defined from R2 to R, where f of x comma y equal to x plus y if either x equal to 0 or y equal to 0. Otherwise what? Consider one point C equal to origin 0 0 since function is defined from R2 to R, and consider direction u equal to in x axis, that means consider this is e1 1 0, then f prime c e1 means actually this would be f prime 0 0 0 1 0, and this value is limit h tends to 0 f of 0 0 plus h u means 1 0 minus f of 0 0 divided by h, and this is equal to limit h goes to 0 f of h0 minus f of 0 0 divided by h, and f of h0 means if we put then this value would be h, limit h goes to 0 h divided by h, this value equal to 1. Okay, that means if we consider d1 at the point 0 0, this is actually the first partial derivative of f at 0 0. This is equal to 1. Then the second partial derivative with the direction u equal to e2, which would be 0 1 at the point similarly or at the point 0 0. Then a prime c e2, this value would be a prime 0 0 with 0 1, and this value is equal to limit h goes to 0 f of 0 0 plus h 0 1 minus f of 0 0 over h, and this value is equal to limit h goes to 0 f of 0 h minus f of 0 0 divided by h, and f of 0 is h is nothing but this is equal to f of 0 h, this is equal to, this would be equal to h. So this value is limit h goes to 0 h over h, this value equal to 1. So d2 f00, which is actually the second partial derivative of f at 0 0, the value is equal to 1. X equal to same point 0 0, but direction is 1 1. Then a prime 0 0 comma 1 1, this value is equal to limit h goes to 0 f of 0 0 plus h 1 1 minus f of 0 0 divided by s, and this value would be limit s goes to 0 f of s comma s minus f of 0 0 divided by s, and f of s is, for this condition here apply, this value would be 1. This value is limit s goes to 0 1 minus 0 divided by s. That means this value is limit s goes to 0 1 over s, and this limit does not exist. I hope my all viewers have understood this is clearly. That means notice in this question I have got all partial derivative exist, but all directional derivative in all direction not be exist. By because in this direction the directional derivative not be exist. Okay, I hope my all viewers have understood clearly. When partial derivative exists, this does not always imply all directional derivative exist. Okay, this is today's goal of this lecture. Today I will stop here. In my next video I will discuss directional derivative also in another way. Okay, see you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.